Hello everyone, welcome to Learning Activity 10 Lab. And we're going to go ahead and jump over to our next learning activity, which is feature engineering, rather using clustering analysis techniques. So go ahead and open this up. We're going to go ahead and open up our Python notebook over here. And while that's getting loaded up, let's go ahead and get a feel for what is it that we are going to do. So database integration for cluster analysis. And you can actually, we're going to copy and paste in some things because we actually have these from prior. So this database integration, go back here and from our notebook sync sessions, you're going to have your PyODBC connectivity. I'm going to cut and paste some things in just to kind of save some time. So the first thing we're going to do for this is we're going to do cluster analysis using tsne and then one for principal component analysis. But first off, let's get our database authentication, our libraries, Python libraries all taken care of. So we're going to do from sklearn .manifold import tsne, and then we'll import seaborn. We'll take a look at that as SNS, and then we're going to import pandas as PD, and then import PyODBC. So those are our big ones that we are focused on. All right, so now after this, we got to create an authentication, and I'm going to paste this from an old notebook over here. And that should take care of us. So get your SQLcon and just drop that in just like that. Remember from there was that bug. Make sure your driver says SQL Server here, or SQL Server ODBC driver 17 for SQL Server. That works too. So that'll be good. Okay, next up, I've got some notes here. I've hand selected some product IDs, mainly because these are good ones for us to take a look at and contrast and compare these product IDs. And I wanted to give a use case out there. So one of the things that we have to be that is on the lookout for is we use these machine learning models. Yeah, that's great. We're using all this fancy stuff. But what do we actually use it for in the real world, right? I mean, that's great what you saw earlier with the toy models, right? But let's actually do something that's a little bit more industrial. So in this case, I'm going to use it for product quality analysis. So we're going to use tsne to do a quality analysis or a semi-quality audit on our product data, using product data rather. So the first thing we're going to do is we've built this up here and create our connection, and now we're going to do a we're going to build two queries. You don't have to do it this way, but it's just kind of it's more simplified from a programming perspective, and because we're not doing tons of stuff, we're gonna we're not pulling millions of records, so we can keep it we can get away with doing two separate queries. Okay, first up, thing I want you to do is we're going to actually do an analysis on, we're going to do a select star from, let's see, I want to say we're going to do from our production.work order. From production.work order. Now for this, what I want you to do is that's the base, and then we're going to be doing something for query 2, same thing, and I'm gonna leave this blank for right now. Now let's go over to our SQL Server. We're going to create and open a new query, and we're going to open up and do some analysis right here just to make sure that our query works. From perfect. Okay. So now what we're gonna do is there's three things, maybe more than three, maybe a couple more. there is, let's see, we've got product ID, order quantity. Okay, so we've got a few things. Let's start off with product ID. So we're going to do product ID, order QTY, order quantity, stocked quantity, scrapped quantity, and then let's do scrapped reason. I think there's a scrapped reason in here. Scrapped reason ID. So we have to do some feature engineering. You see these nulls? That means that there's no scrapped. But so we're gonna say we're gonna use the is null function. But let's just pull it in right now, and then run that. And this is perfect. Okay. Yep, that's all I need to see for right now. Okay. Now on this one, we can pull this across, but these nulls are going to cause problems for us. I want to say where there is a zero, or I'm sorry, where there's a null, let's put a 0 in there. So let's do it is null. That's a SQL function 0. So anytime that encounters a null, put a 0. Else it's going to leave it alone. And then we'll say as scrapped bit. Oh, that works. Okay. And then yeah, okay. So then that looks fine. Let's go ahead and post this over here. And one of the things we can do is, remember when we do this, we have to do we can put it all on one line, but this just makes life easier, a little cleaner. We'll do this line, this string string continuation. Okay, that looks pretty good. Excuse me. Now let's go and do an analysis on. Let's build the rest of this out. So load. Let's do an X. We can pull this actually from what we had done before. But let's go ahead and build this out. PD.read SQL. We just have to type it out once. Query 1 SQL con, and this is the data. And then we're going to copy this down, and then this is the target. Y is the target. And this is going to be SQL query 2. All right. Okay. So for this SQL query 2, we're going to do the target on this scrapped reason ID. I'm interested in doing some analysis on that. So basically, all we need to do is select, it's basically this query. And then we're just going to do this. Is reason, and then as scrapped, we don't actually have to have the scrap bit for this one because it's just the target. And I think that's all we need. Okay, so let's build the rest of this, and then I think the rest we can actually pull, we can copy over. So I'm gonna do this was this is just copying over from our last exercise. This is the same thing. We're going to initialize tsne. So initialize tsne framework. All right. And then here we're going to set the data frames. We're going to come up here, pop that in. And then let's see, let's make sure. Yep. This is the target, so this is the scrap reason ID, because that's what this is right here. But we're changing this to a scrap bit. But if it's null, we're keeping it 0. If not, we're keeping it the reason ID. So leaving it alone, in other words. Okay, now we've got this is all copied from tsne. So in other words, these don't change. This is reading the data frame from what we've created up here into a component 1 and a component 2. And then let's create a scatter plot. Again, this is that t-SNE data projection. We can just copy this over too, because we just built this in our last learning activity. Okay. Now the last thing we want to do is we want to do it on these groups. So remember over here, we need to put a where clause in this. So we need to say where, let's see, where product ID in, and then I think we said, what did we say over here? Let's do this one first. Product ID in. Yeah, that's all we need. Let's just make sure it works over here. It's always a good idea to make sure your code, your SQL code executes. Yeah, this works before you pop it over here. So we just need that where clause. So we can take this where clause and then put it in right here. Yep. And then same thing here. These both need to be lined up. Now, the one thing you could do is you could technically make this one query, but I'm making these two separate queries so you'll understand that query 2 is the target. So these scrap reason IDs, these are going to pull in the exact order that they need to pull to make this all work. So there's nothing, like they're not going to be out of order or anything like that. So these will all pull properly. Okay. So I think that's all we need. Let's go ahead and run this and see if we can get ourselves in trouble. All right, still running. And you can see, now one thing I want people to keep in mind is, as we're running this, t-SNE is queuing up. It's taking a bit to make this work. So I'm gonna pause, and this is one of the reasons why you want to. t-SNE is a great way to do it one way, but there's also other ways to do it with, as an example, PCA. But again, this still is a useful exercise. Let's see. Hopefully this gets done pretty soon. All right, it's starting to make some headway here. It's still running. So it's in this case it's running on 21,000 samples, and then 43,000 or 4,300 targets, and then it's still running. It's doing a KL divergence. This is pretty good. KL divergence after 1,000 iterations is 0.17. And then there we go. So we finally got a t-SNE data projection, and this looks good. Now you might say, hey, that doesn't tell me a lot. But what we're looking for here specifically is we're going to be, this only makes sense when we run these through more and more. So I've already set the use case up. So that is so super critical to understanding. You can't just make a t-SNE or a cluster analysis without having a model in mind in terms of what you're trying to accomplish. So in this case, I've created an audit model, so to speak, a quality product audit model using t-SNE. So what I did here was I said the targets I'm looking for is the scrapped. So if I have a reason code, so 0 means because of the isNull function we did on the SQL side, we did some feature engineering to create 0 because that shows us that these are product IDs that do not have anything that has this light dot. Those are products that don't have clusters, that don't have a scrapped reason. Anything that's above that, 3, 6, 9, 12, 15, those are scrapped reasons we need to be aware of. And you can see we've got quite a few in this product group. So we just did a t-SNE analysis, and there's no way that we could do that easily by saying, hey, do an analysis. But we did a spot check. We did a sample on a product grouping. So 324, 331, and 401. We took those product IDs, and I kept them small because I don't want these data sets to get super huge, but I'm illustrating a point. If I'm taking this to a board, this actually is something that I can use by saying that those product groups, I've got some quality issues because we spotted them in a cluster analysis using t-SNE. Now, for comparison purposes, that's why we want to make sure that we understand what it is that we're getting ourselves into. You can't just do one model and run it once and then say, hey, I've got the secret sauce. You've got to run this a couple times and compare this against other product groups. So in this case, I've selected a particular 818, 896, 944, and 946. So you have to, in this case, I've created, you have to line these up because you got to to be careful. So let's run this again and then see what we get. It should run a little bit faster now that it's queued up in memory. It's already blasted through quite a bit faster. So we'll see what this does. All right, and that's a little bit further. Now, in this product grouping, we still have the same defects, but not as many. You can kind of see in the first one, we've got, oh my gosh, I mean, it was all over the place. But we've got product defects that are popping up still. It's a little bit better, but not quite as good as what we saw earlier. We can still use with certainty, see this KL divergence after 1,000 iterations. That's pretty good. So anytime this is usually the way you interpret these, and again, this isn't meant to be like the end all be all. You can still use divergence metrics that are higher, but typically the lower this number, the better the model is at keeping information loss to a minimum. That's usually what this means here. So anyway, lower numbers are usually better. Okay, now let's see. Let's go back and rerun this, but we've got another one to check here. So I'm going to rerun this with this. So I'm going to paste these in. And this, I got to tell you, this is why it's critical to know SQL and Python, especially when you're going to do artificial intelligence as it relates to organizational artificial intelligence. There's just no way that you can do this and not and be in rather be in a position to be able to integrate these and navigate between these without having comfort in both of these areas. So that's why we spent so much time in SQL. So and this is where it kind of all comes together. So now I'm going to rerun this, and we're going to rerun this on this last set of product IDs. And there's actually a secret with these product IDs that I found after looking at the data set. So this is running pretty good here. All right, so now this is even better, right? I looked at what we looked at 2000 the data set. It had 2,555 with 511 target samples, and in this case I've got 15. So 15. So in this case, across this product line has the best quality of the three product lines that we picked. So product groups rather. Let's rephrase that. So this product group had the worst quality. This one had a little bit better, but still kind of had a rough problem. And then this one had the best quality of all of them. Showed a scrapped ID of 15. But one thing that you will notice if you want to, rewind this video. We don't have to replay it, but rewind this video, go back to the beginning, and look at the product IDs. One of the things that popped up that I noticed when I was doing this analysis was the scrapped ID for 15 showed up in every data set. So that's something that's a data point that's of interest, right? So while there's a couple things, right? It's like, why are these lower product IDs suffering from more defects, whereas the higher product IDs are not suffering for as many product defects? And at the same time, scrapped reason 15 is exhibiting itself through all three product groupings. So that's something that's interesting, right? That's something that a board would be very interested in learning about, and how do we rectify that? What do we need to do? What do we need to fix? But it gives us something actionable to run off of. Again, using our data here to our advantage. Now, with this one in particular, one of the things to be cognizant of is we selected these from this. There could be other things that we looked at, but it requires a level of comfort between bouncing back between SQL on this side and Python on this side to create a model that matches with a use case for a specific output, in this case for product quality audit. So this is a real useful tool. This could actually be something that you'd use in a board presentation. Maybe not to all this detail, but you could certainly take these graphs and these outputs and reference them, uh, of course not without all this detail, but back to a game plan. And by saying that you used machine learning, and in this case t-SNE, to isolate the problems and spot them. Okay. Let's see. Now that we've got that done, let's go ahead and move over to principal component analysis. And so in this case, we're going to be doing a use case of product behavior across sales territory. Again, back to finding a use case that's going to work for us. And what we're going to do is use PCA, and you're going to see the big difference here. PCA for the purposes of this sales analysis by territory, but and if you want to learn more, there's some good stuff here as it relates to space-time complexity. We don't have enough time to talk about that here, but computationally, when we talk about things that in the machine learning world, big theta or big O notation styles, or what we call space-time complexity, become very apparent and very important in doing analysis, because machine learning algorithms, they can sometimes take a really long time, and you need to get a feel for, like, am I going to be waiting a day, a week, or a month for this analysis to return? That's a very real thing that used to be the case, I'd say, especially back in the 90s when the compute power wasn't there. It's less so of an issue now, but you'll notice the reason I bring this up is t-SNE was giving me some compute problems on my laptop. It probably wouldn't on a server if you're running this, and you're doing this in an automated fashion to provide reports, or assembly line feedback. But in this case, principal component analysis, you'll see the big difference here in terms of speed. So if you were ever in a situation where speed is of the essence, or the time complexity to affect a certain computational output, then you definitely want PCA if time is part of your calculation. Okay, so let's jump into this. I'm actually going to pull over our standard stuff. So import, I'm going to import these, pasting these in. So two new ones that you're not familiar with is from sklearn.decomposition, import PCA. So that's the decomposition I was talking about in the lecture. And then the other one is sklearn.preprocessing. I didn't talk about this one in the lecture because I wanted to talk about it here. I did a little bit in terms of standardization, but standard scalar. And then what we're going to do is we're going to pull in our authentication. So let's pop this in. We actually can pull this in from the top up here. We can just copy this. All right. And then extract and transform. We're going to do a query 1. And we can actually copy that from the top too. Again, anything to help save us some time. So we just need query 1. All right, query 1. There we go. But we're actually going to be doing an analysis on sales.sales order header. So we're going to pretty much make this a lot simpler. We're going to take this and pretty much get rid of all that. Just save. There you go. Okay, from here, we're going to do let's go back over here. So for our second query, let's just make sure this is going to work. So we're going to do a select star from sales.sales order header. Okay, and then we're going to do territory ID. Oh, well, let's do star. Let's do star. So we're going to run this, and then we're going to have a lot of information here, and we're going to pull in territory ID as a target. Then we're going to do order date, status, online ordering flag. Where's online ordering flag? Ship method, total due. So we'll grab a few of these things. Ship. Let's see. Online order flag. There we go. Territory ID. There you go. ship method. All right, there we go. Cool. Okay, we've got everything we need. All right, so let's do this. Territory, Tory ID. Then we're gonna do order date, and then we'll do status, online order flag as flag, ship method ID, and then the total due. Okay. So I think that's all we need. We're gonna have to do a little feature engineering on this because this order date, that's not gonna work for us. So this is gonna be territory. We have to pass a target, so we have to say as target here because that's the column header that the data frame is gonna be, that we're gonna pass to the data frame in our code, so that minimizes how much code rewrite we have to do in Python. This we have to do some feature analysis because this isn't going to process the way I want it. So I want to do month. So I'm going to use a month function, if you guys remember that, as order date month. And then status is fine because that's numerical. Online order flag is fine, and total due is fine. Yeah, these are all good. So we can take all this and we can run with that. Let's just make sure it runs, and that is exactly what we need. Okay, so remember in this case we can't use principal component analysis on textual information. We got to have numerical data, so we have to do, that's why we had to do some feature engineering here so that PCA can pick this up. So let's get this integrated. There we go. All right, now that we've got our query, we can actually just do, we can paste this from above, so we can get this data frame. We got to get this this query one's taken care of. We can get this PD read right here. We can just grab this one because that's exactly what we need, and save ourselves again some time. So right after the query, we'll do this, and then we'll do a df to write it to a data frame variable that we can get access to. And then after that, we have to do what's a feature analysis. So we're going to do, we have to pass in features equal to, we'll do, whoops, like this, and we'll, like that. Okay, perfect. We'll say, let's see, we want to do order date month. So these features up here, this is what we're gonna pass in. We're gonna keep this pretty concise here for the target. So we'll just use one query is where I'm going. Okay, so then next up we're gonna do status. Status. We're gonna do online order flag. We'll do ship method. Well, ship method ID, I think. Yeah, ship method ID and total due. Okay. All right. Perfect. Let's run this. Make sure that all works. It should get no errors here. Yeah, that's okay. Okay. So now that we got those features in here, we have to be real clear between this and this. Make sure that as you double click, that'll make sure that they match, and they do. Okay, so now what we're gonna do is we need to do we're gonna do a print, and I'm gonna do /n PCA input, and then we'll. Okay, this is just to there we go. This is to make sure that in our console return that we have a clear delineation of what I'm about to type out next. All right, so capital X equals to df.loc, which is location, data frame location. And I'm going to say features dot dot values. So what this is doing is it's setting up the X, and then we're going to do the same thing for Y. And then we'll say this is the target. Come on. There we go. But here what we have to do is we actually have to pass in the target name dot values. And this isn't going to work unless we won't be able to graph it if we don't have this. That's where I'm going, and so that is definitely required. So we're going to take X, and then we're going to do a standardization on the X data or the features. So this is all the data features, all data features. And then what we're going to do is we're going to recall it, and then we're going to use a standard scalar to standardize the features. And do a fit transform all at the same time. Transform X. And then, so we're going to standardize and transform. Standardize and fit transform in one step. Okay. But we're going to have to do another fit transform down the road too. So we're not completely out of the woods. Then we got to do a PCA equal to PCA, the actual object. And just like we did with t-SNE, we have to give it components equal to 2. And then this is setting the PCA projection. So set PCA projection in 2D. That's what this is. We can take that, and take this off. All right. Okay. So then now we're going to do principal components equals to PCA.fit transform. We got to do it one more time. And then let's see. We have to do a principal.df and equal to PD.data frame. Data equal to principal components. Principal components, columns equal to, and then this is setting us up for this is passing in the actual individual component vectors. So this is we don't have to call it that, just call it principal component 1, and then same thing, principal component 2, principal component 2. Okay. Okay, I think that's all we need for principal DF. I don't think we need anything else there. Yep, that looks good. So next up, we have to do a DF on the target. So we got to create the, let's go with, yeah, and then target. Head, and let's see what that looks like. So we'll display what the PCA input looks like. This is for debug purposes, just to make sure that we're all good. So I can simplify this quite a bit more, but I'm adding in a little extra so you can see what's happening at each step. Okay, so then final df equal to pd.concat. And then what we'll do is principal.df, df, and then target 1, 2, 3, and that's correct. 1, 2, 3 axis equal 1. Okay, and then we're gonna print the data frame. Print pd.data frame. Whoops. Data frame equal to data equal to x, columns equal to features, and then we'll do a head on that. Okay. All right. Well, let's run this and make sure. Let's make sure we get what we're expecting here. See if we did this right without any errors. Oh, that's working so far. Oh, wait. We got one little problem child in here. What is it? Name of index target object are in the columns. Oh, okay, so let's check that out. Let's see what we did wrong. All right, I think if it's saying this a target, it's probably up here. I've screwed something up on line 28. It looks like. Okay, so let's take a look at this. Target. I see. I have a bracket in here that's not supposed to be there. Let's see. That is correct. I think that's what we. I think that was. If you had that bracket there, just as FYI, that bracket's in the wrong spot. You can just remove that. That's what the issue is. So let's rerun this. We should get a. Yeah, there we go. Perfect. PCA input. You see how quickly that processed that. Pretty quick. So now that is just printing the data features that we're processing, but it created it standardized all the variables here. You can see what it did here. That's what a standardization does. So it standardizes everything within the data set. Now this isn't the same type of standardization we were talking about earlier in the class, 0 and 1 versus unstandardized, that between correlation and covariance. These type of standardizations are a little different. They can have broader swings. I want to say 6 to -6, but I wouldn't quote me on that. But typically that's kind of the standardization. Sometimes it can be different scales. It just depends on what you're doing. Okay. Now, and just as an FYI, you can do standardization in SQL if you want using a rank scale function. So you can do that before, you can do SQL for pre-processing before sending it over here too if you wanted to go that route, which I have done in the past. That's something that's totally legitimate and totally totally available for you. Okay. Let's finish this up. So we did PCA input. We got that working. Now let's get the PCA. Let's do a quick PCA output and look at what the final. So I'm going to copy this down and then output PCA output. Oops, output. And then here, what we'll do is we'll do a print final df dot head, and we'll do the top 5. All right, run that. Okay, I think that finished. Yeah. So now what you got is this is the PCA output. This is cool. So we took this. This is why I wanted to show it this way. You can see line by line what's happening here is the PCA output. I've got these. This is the input 1, 2, 3, 4, 5. This is the standardized input. Now this is the eigenvalue calculated component vectors on the PCA output. So here I've got principal component 1, and then these have all been decompositioned or dimensionally reduced into principal component 1 and principal component 2. And then these are the target vectors that we're going to be using for our analysis. Okay, so now let's do some model information. Okay, so we're going to copy this, and then we'll do some PCA model information. And then what we're going to do is we'll do a final df count. Ooh, not count star, just count like that. And then we'll do PCA dot explained variance ratio. And then PCA. Usually metrics or algorithms or estimators have explained variance ratio or scoring mechanism, sometimes score. And then in this case, I think, yes. So one other thing that we need to do is let's put in print the total variance explained. And then in this case, we're going to, as I mentioned in the lecture, this is one thing that we're going to do a sum of the PCA that explained variance ratio. Yeah. Okay. I think that's all we need. Let's rerun this again and see what we get. Perfect. So now we've got principal components, principal component 2 with target. That's perfect. We have a D-type int64. This is actually the explainable variance that we got, which is actually pretty high. If you look at it, 0.86. That's pretty good. Usually anything with the total variance explained over, I'd say 0.7 is something of interest. Anything below that is kind of, you could probably get away with something in the 0.65-ish, but I probably wouldn't go, you need something higher than that. Anything over 0.8 is definitely fair game and something. So we're on to something here. Now let's go ahead and let's build out the code for the matplot. So let's do this, and let's do that. Code for matplot. Code for PCA matplot. Code for PCA matplot. All right. Okay, so this is to visualize, to help visualize what we're seeing. So let's build this out. So we're gonna say fig equal to plt.figure, and this is gonna make the figure big for us to kind of look at, equal to 12. So it's gonna expand it, and then we're gonna create a subplot equal to fig.add subplot, and then this is gonna be 1.1.1. And then we're going to set the labels, ax.set x label, and once we label, once we get the 1, we can copy it. This will go a lot faster. Principal component 1, and then we'll say font size equal to 15, and this is all just kind of formality for formatting, that kind of stuff. Font size, this is Y label, set the Y label, set Y, and then ax dot set title is going to be, we can copy this actually, there we go, font size equal to 20, make it a little bit bigger, and then this is going to be title of 2 component PCA. And now we got to set our targets. So targets in this case is going to match our territory ID, which we know. So we've got to go take a look at something here. So let's go take a look at these. So if we've got territory IDs, we need to go take a look at what territory IDs do we have. So if we go to, where is sales territory? Here we go. So let's go take a look at our territory ID. So we need to say select star from sales.sales territory. And now let's do distinct. Oh, we may not have to. Hold on. 1 through territory IDs are 1. Yep, no duplication and no more than 10. So there's 10 territory IDs. Okay, that's perfect. So that's what we need to know. So targets have to be set up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And these are our targets, territory ID targets. If you change these, then you got to come in here to match these to the data. So if this was like ship method ID, then you'd have to go get the ship method IDs and then bake those in here. So that's one of the things. Now you could make this all programmatic, but I want to show you and make it more explainable to you in terms of what's going on here. So colors, colors is in this case going to be pretty simple. It's going to be C, comma, And then and so these have to correspond, these colors have to correspond with the numbers up here. So you've got to create 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Last one that. So I'm gonna create a color spectrum where these are, the first two are CC, the next two are yellow, the next two are black. That way we have a corresponding next to, or I think blue actually, red, and then M and M. I think that's good for now. 1, 2, 3, 4, 5. So yeah, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we're good there. And then now what we have to do is actually create a for loop for our our plot. So we're going to do for target color in zip, and in this case zip targets. I could call it whatever I want, but targets colors. And then this is a for loop, so indices to keep equal to, we have to make this the final df, and then target, and we're going to be doing a conditional, so we're looking for where they are target. Comparison, sorry, not conditional, but comparison. And then we'll do an ax.scatter. So this plot is more complicated than the other ones, but there's a reason for why I'm going this. I want you to have other tools in your toolkit here. And then this has to be for indices to keep. And then we're going to say principal component 1, and then we're going to do comma final df location indices. Actually, we're actually copying this up here. Copy that. This is just save us time typing. There we go. Indices keep for 2, and then we're passing in. Come on. Passing in. There we go. Passing in C equal to color, and then S equal to, that's size, S equal to 60, and then we can close this out. I think that's all we need there. Now let's put a legend on it, ax.legend, and then targets loc equal to center, so we're putting location equal to center left, and then this is all again more formatting, to anchor equal to 1, 0.5, and these are all parameters you can play with. ax.grid, and then plot show. All right. Okay, ooh, that's quite a bit. Let's run this out and see what we get. Let's see if we can, oh, and then of course we got an error. Fig size, let's go up to that. Positional argument follows keyword argument. So fig size, figure size. Okay, what did we mess up here? That has, I'm missing a parentheses. Yeah, this is supposed to be wrapped. Yeah, so the fig size is like that. It's got its own parentheses. I missed a paren there. Okay, hopefully that's it. Let's give this a whirl. See what we get. Okay, that completed, and sweet. Look at that. Now I got a nice looking 2-component with a grid. I've got it outlaid with my eigenvalues on the 2 principal axes, and I've got this code for my PCA with a PCA output, and this looks great, and I got a really nice look. So what does this tell us when we take a look at this? One of the things that I would say that you would want to be on the lookout for in this analysis is the this 2-component PCA here. it's based on the territory IDs. So these are the territory IDs. But one thing that is jumping out at me, based on this analysis, is that we've done all this and we've done this select territory ID, but we also added this month order date. So we've got a month order date as order date month, and that's one thing that I have a sneaky suspicion that's what these are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is correct. So there's a certain amount of interpretation here that we have to go into this PCA, but this actually gives us an interesting view because what this is showing is clustering by month. So this is month 1, month 2, month 3, month 4, month 5, month 6. Now you wouldn't know it looking at this, but we know the data enough to know that this is pretty much what it looks like, right? It's ordering it based on that. Why? Because we know that our summer months have the higher, because of our order quantity count, which we did. Did we add that in here? No, we target order status, online order ship method. Well, it's our sales order header, so we know that there's a total number of counts that have been shipped into that. So there's a density of the data showing and exhibiting itself, even though we didn't put the order quantity in here. We could do that and maybe get another data point, but this does show and coincide with what we've seen because we've kind of got a dip as it relates, and then it starts to increase over here. It's really more the size because it's with PCA type work. It's you get this dimensional reduction. You have to be careful with what is it that we're actually interpreting. Okay, so these are the territory IDs, and what this shows me is that territory ID 10 is operating really well. So I think from this perspective, this is looking pretty good. But it looks like they all are. 5 and 6, territory 5 and 6 are doing pretty well across all of these. So this looks nice. And what this is showing is just another view, but also that maybe I've got to set a transparency on this, and that's something that we could actually do if we wanted to do a follow up. But again, I don't want to take up too much more time because this is already a long one. But what we probably do next is set a transparency up on this to see what we have behind these, to see, because there is some overlap on these. It's hard to tell fully, but you can see some months are doing better. Like for example, there's some tendencies where territories 5 and 6 are really big. You can see blue, 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 real blue, a lot of blue here, but hardly any 9 and 10. Territories 9 and 10 aren't really playing in the month of what would probably be April is what it looks like. But we got low volume in April, but blue is helping us out in this area for April. Same thing for what looks to be February, right? Blue's doing really well, picking up the pace, whereas purple isn't really. So territory 9 and 10 aren't really competing that well in those 2 months, and that's something to kind of be on the lookout for. Whereas territory 10 is doing great in month 1, in March. Let's see. Kind of spread throughout the rest of the way. Yeah. So there's an interesting trend in the data, just looking at it right here, where 5 and 6 they're doing really well in the earlier part of the year, and kind of keeping us afloat. So that's some interesting things to kind of be looking at. All right. Now that we're done with that, we're done with PCA. What I want you to do is, using TSNE and SQL, cluster and evaluate the following data, and I've got a select statement for you to do, and I want you to evaluate it, but using what we did, using TSNE, not PCA, because you can see I put a lot more effort into putting PCA together for everyone here. Do TSNE and try to get TSNE working for yourself on this example for this async. And that's all I have for learning this learning activity 10 lab. If you got any questions, hit us up on Slack. I know this was a longer one, but we had a lot to cover in terms of getting TSNE and PCA working. And with that, I will see you in Learning Activity 11.